Hey everybody, I just wanted to go over some sample problems that you're going to see that can help you study and get ready for the test. Now, these problems aren't, I'm going to be that guy, and so that these problems aren't necessarily going to be on the test exactly, but the concepts behind them will definitely help you in studying for the test. The thing to do is probably to try to work through the problem on your own and then see if you can get the answer or get as far as you can without getting, or when you get stuck, then go from there. But we're going to look at, as the calculator says, we're going to look at this question right here, 15.49 in brown. And so you feel free to look along and go along with it. So we have this reaction where I2 is reacting to form I. Okay, they're both gases, and we're given an equilibrium constant. Now, let's keep in mind that there's only two types of problems, okay, whenever we do equilibrium. After we get through some of the manipulating the equilibrium constant and stuff, there's really only two types of equilibrium problems. There's determine the conditions and determine the constant. Okay, so when I look at this problem, I see that the Kc is given to us. So Kc, I'll put this over here, Kc equals 1.3? Oh, 3.1. Okay, so 3.1 times 10 to the minus 5. Okay, and so the idea is we want to know what the equilibrium conditions are. I know that that's going to be what it asks for. Okay, it says how many grams of I2 are in the mixture. Okay, so that's a value that you can get from knowing what the equilibrium conditions are. Okay, and that's one of the things that I think is valuable to understand, is that once you get to the end conditions, we can then figure out what the, then we can convert that to all those meaningful pieces of data, grams, moles, liters, whatever it is. Okay, but here we have a 10-liter vessel, and it's 2.67 times 10 to the minus 2 grams of I gas, so this thing. Okay, so let's go back here. So it's so given is 2.67 times 10 to the minus 2 grams of I, and it's in a 10-liter container. Okay, well, that information is going to give us the concentration. Okay, once we have the concentration, remember, let's see, ICE, we can calculate we can use the Kc to get us those conditions. That's going to be the concentration of I squared over I2. And so once we have that, we can calculate, once we have, well, we have this, so once we can figure out the value of I, we can then figure out the amount of I2. Okay, so let's do some math. So we need to get to the end value here, the equilibrium value. Okay, well, that has to be wrapped up in these numbers. So it's 2.67 times 10 to the minus 2 grams. And I like to use this thing like the X, that's called the X line. It's just setting up a multiplication problem to do your conversion. And so it's going to be grams, and we're going to convert that to moles because we want concentration, which is in moles per liter. Okay, and so we use our periodic table, and we find out that the mass of iodine, I, is about 127 grams per mole. So to convert grams to moles, we're going to go for that 127 grams for every 1 mole. And so we go 2.67, 2.67 times 10 to the minus 2 divided by 127, and so that ends up equaling is equal to 2.1 times 10 to the minus 4 moles. But now we want it in concentration, so we take 2.1 times 10 to the minus 4 moles, and we are going to divide it by 10 liters. Molarity is moles per liter, so we take that and we divide it by 10, which means we're just going to move the decimal point over. So that's 2.1 times 10 to the minus 5 molar. Now we come back up here, and so this means that if we started with 0 here, this is plus 2x, so this is 2.1 times 10 to the minus 5. Okay, now this is how we have to manipulate the ICE chart here. So this is going to be some value. Okay, let's go back. Does this have an initial value here? Okay, it just says how many grams of I2 are in the mixture. Okay, well, that's good enough. So watch what we can do. We can do this, because then if we have this, then we can calculate this value right there. Okay, I can put that in a different color so that you can see, right? Okay. Okay, so if we have this, which is this, we can calculate this. We can find that out right there. Okay, so do we have a KC? Yes, we do. Okay, so we have KC, which is 3.1. So I'm going to put a little thing here, right? And that way we know this is the other part of the problem. 3.1 times 10 to the minus, what was it, 5? 10 to the minus 5. 10 to the minus 5 equals the molarity of I. The molarity of I we just found out to be 2.1 times 10 to the minus 5 molar. And that's squared over the concentration of I2. So now we can do the math and we can figure out what the concentration of I2 gas is going to be. Okay, so we do 2.1 times 10 to the minus 5 squared. And now in order to get this in the right spot, we switch these two mathematically. Okay, so then we do divided by 3.1 times 10 to the minus 5. Okay, so we get that the concentration of I2 is equal to 1.4 times 10 to the minus 5. Okay, that's how much I2 we would need in order for this to reach equilibrium. Okay, now let's just double check that we answered the question. How many grams? Oh, look at that. So now we have to go to grams. Okay, well, that's molarity. And so now, if this is molarity, we can go back through the steps. Okay, so 1.4 times 10 to the minus 5. Let's see, molar. So that's moles per liter. And now remember that's in a 10-liter container. So times 10. Look at what happens. Liters cancel, leaves us with just moles. So that is 1.4 times 10 to the minus 4. And now we want to, and now what's the only unit we have left is moles. So now we want to convert that to grams. 1.4 times 10 to the minus 4 moles. And I use that X line again, moles per gram, or grams per mole. And so let's see here. For I2, the mass is equal to 2 times 127, which equal, let's see, 2 times 127, and so that's equal to 254 grams per mole. How many grams? 254 per 1 mole. And so now we take that multiplied by 254. Whoops. 1.4 times 10 to the minus 5 times 10 to the minus 4 times 2.4. 254. And so we get that we need 0.036 grams of I2 in order for that to be at equilibrium. So if we look at this, really, this problem, there's only really a little bit of equilibrium here, okay? This is equilibrium. This here, this is stoichiometry through here, okay? And now this is equilibrium, and now this goes back to conversions and stoichiometry again. So you have to be a little bit proficient in some of these conversions, going from, liters to milliliters and grams to moles and moles to grams, and knowing what molarity is. Okay, so I hope this clarifies this question, and have a great day.